Okay, so we've looked at finding the probabilities under a curve using our 68, 95, 99 rule. But what happens when it doesn't fall within that piece? How do we calculate it? Well, our calculator can do these calculations for us. So some things that you're going to have to remember, this is your GDC rules. If you hit second vars, which is distributing, or distribution, I should say, and then number 2 is going to be normal CDF. Those are the keystrokes you're going to have to use to get your probabilities that are going to be underneath that curve. Now, we will talk about going to negative infinity and positive infinity. So when I'm saying, what I'm talking about there is, let's say that I told you I wanted it to be more than 50. Well, this is going to be x is greater than 50. So that means I'm going to positive infinity. I'm 50 or more. And so that's when we're going to have to use 1E99. And that E, to type that, you're going to hit 1. And then you're going to have to go second. And then it's the EE, which is above 7, I believe, on the calculator. And then you hit 99. And that's going to be how you type that into your calculator. And then on the flip side of that, if I said instead of more than, I said less than, then obviously our sign is going to flip. So then 50 is the maximum, but then I'm going to negative infinity. So the only difference is you're going to put a negative in front of that one and then hit second EE and then your 99. Okay, so let's just practice some in the calculator. So for part A, I'm falling between 8 and 11 on this problem. So for your GDC, you're going to go second vars, number 2, which is your, it's going to be normal CDF, and then if you're on an 83, you're just going to type these numbers in. You're going to say 8, 11, 10, 2.3. So it's essentially something to remember. It's going to be your low, and then your high, and then your mean, and then your standard deviation. That's how we're going to type that into our calculator every single time. If you have the 84, it's more spelled out for you, and you'll see you just type in those numbers where it's asking it for. So when you type that in, you hit enter, and you get 47.6%. So the probability, if you have a standard deviation of 2.3 and a mean of 10, the probability of you landing between 8 and 11 is 47.6%. Okay, so then part B, I'm going to erase this here. Part B is saying I want it to be less than or equal to 12. Well, I'm less than 12, which means I'm going to negative infinity. So remember, we're going low, high, mean, standard deviation. That's how you're going to type that in. So my low, since I'm going to negative infinity, is going to be negative 1 E99. And then in that E, really, you guys it stands for scientific notation. So it's really negative 1 times 10 to the 99th power. So that's where you're going. And then your high is going to be 12, and then your mean is 10, and your standard deviation is 2.3. And when you hit enter, you're going to find that it's going to be 80.8% rounded 3 sig fig. Okay, and then the last one, we know we're still going to have our 10 and our 2.3, but now I want to be greater than 9. So now 9 is my low, and I'm going to positive infinity. So I'm going to have 9, 1E99, 10, 2.3, and you will get a percentage of 66.8% rounded 3 sig fig. Now let's look at a word problem and how do we use this. So we have the heights of rugby is normally distributed with a mean of 179 centimeters and a standard deviation of 7. and I want to find the probability that it is at least 175 centimeters tall. So we're looking for the probability that your person is at least 175 centimeters tall. So there's our inequality. So we're going to do that normal CDF. So you're going to do second vars and then number 2, normal CDF. And then because I'm greater than 175, that 175 is my low, and I'm going to positive infinity. And then my my mean is 179, and my standard deviation is 7. And then when you hit enter and you type that in, you find that you get 71.6% rounded 3 sig fig. So there's part A. Now part B is going to be, I'm going to erase this part here. So now we're finding the probability that we're falling between something. So now my low is 170 and my high is 190. So when I do my normal CDF, I just have 170, comma 190, comma 179, comma 7. And when we calculate that, we find that we get 84.3% rounded 3 sig fig. So same concepts, it's just taking it a step further. Okay, so now let's just look at a general one, and then I want to show you how to illustrate that, because sometimes you will have to be able to draw that graph. So I'm giving you a mean of 40 and a standard deviation of 10. And this one's just falling between your 37 and 48. So you're going to do that normal CDF. My low in this case is 37. My high is 48. My mean is 40. And my standard deviation is 10. And I find that it is rounded 3 sig fig 40.6% when I calculate that with my calculator. So then what does that mean on a graph? So we're going to draw our bell curve. Your mean is 40. So think about where your low and your high fall within that 40. Well, 37 is going to be here-ish. And 48 is going to be here-ish. And that shaded region is the region that you are looking for. And that shaded region is that 40.6%. So that's how we would illustrate that on a graph. The next one, let's just try one more here. So now we have greater than 45. So we're going to do normal CDF. And because I'm greater than 45, 45 is my low. And my high is positive infinity. And then I have a mean of 40, and I don't remember what our standard deviation was, 10. And when we calculate that, I get 30.9% rounded 3 sig fig. And then again, graphing it, so here's my normal curve. Always put your mean in, which is 40. And then we're talking about greater than 45. So 45 is going to fall above 40. And then I'm talking about everything that's above that. So that shaded region is going to be what that 30.9% represents. And then the last one here, we have less than 26%, or 26, excuse me, so you're going to do that normal CDF again. But because it's less than, my low is going to be negative infinity. My high is 26, my mean is 40, and my standard deviation is 10. And when you calculate that, you get 8.10% rounded 3 sig fig. So then, if we were to graph that, I'm going to just erase this here. So we draw our bell. Here's my center. But now I'm talking 26. Well, 26 is going to fall somewhere over here. And then I'm talking about everything that's below it. So that 8.1% is going to be that.